right, our next problem was a counting problem. And we figured out how to use these combination numbers to solve some of these counting problems. Specifically, we were interested in counting number of different ways an outcome in a binary outcome situation where we said successes or failures could happen. For example, if we threw 3 coins, a success would be heads. So how many ways would there be for there to be 2 heads in 3 coin tosses? And so on and so on. But this was a general tool for counting outcomes across kind of binary events. So, again, for example, if we threw 3 coins, we wanted to see how many ways were there for us to get 2 heads. We have this Python function com. It lives in the scipy special module. And we use it just like expected, okay? We say it asks for how many things we're choosing from and then how many things to choose. So from 3, choose 2. There's 3 ways to do that. All right, so if we were to toss 3 coins, it seems that there would be 3 ways to get 2 heads. And that should be easy enough to verify. This just gets hairy when we have a lot of coins, but with just 3 and 2 heads, we could have heads, heads, and tails. We could have heads, tails, and heads, and we could have tails, heads, and heads. And there are the 3 ways that we could get 2 heads. But if we toss 3 coins, there's more outcomes that could happen. Not only could we get 2, right? We could get 0 heads, we could get 1 head, we could get 2 heads, or we could get 3 heads. So oftentimes we're going to be interested in all of these outcomes. So we would do something like, for the 3 example, we're choosing some number I. Well, let me make this a little more transparent. From 0, 1, 2, and 3. And there are all of our possible outcomes. So this is how many ways there are to choose 0, 1, 2, and 3. Or how many ways there are to get no heads. That would just be all tails. 1 head, 2 heads, and 3 heads. And further still, we were interested in generalizing this to not only 3 tosses, but what if we had 4 coins, or if we had 5 coins, or 6 coins, and so on. So we built a little triangle, often called Pascal's triangle. And we just did this same thing, looked at the combinations over a range for each row. All right, so we started with 0. This was 1 coin. Right, we could get either 0 heads or 1 head. 2 coins, we could get 0, 1, or 2. 3 coins, 4 coins, and so on. Okay, and again, what we were usually interested in was exploring all of these possible outcomes. So let's look at row 7 here. And let's make a plot of this. Sorry. And there we go. There's all of the different ways that these things could happen. If we look at these events on the x-axis as number of heads, You know, if we toss 8 coins, or I'm sorry, we toss 7 coins, how many ways are there to get 0, 1, 2, 3, 4, 5, 6, or 7 heads? So you see that there's that symmetry again. It's equally likely that we could get 3 or 4, 2 and 5, 1 and 6, 0 and 7. And there's a total number of outcomes of however many, what's the sum here? Okay, 128. So there's 128 possible outcomes. But 35 of those are 3s. And we know that because of this, the height of this bar and the area kind of this bar. If we think about each of these as kind of one unit, it's a big rectangle, that's 1 by 35. Out of all of this rectangles, which add up to 128. So we could understand the probability of getting 3 heads as 35 out of 128. 35 out of those 128. And that's how we're going to start to use these distributions. We're talking about probabilities, and that really comes down to computing an area of, in this case, one of these bars or a couple of these bars, and looking at that out of the total area. All right, and the total area is just the total number of outcomes. So we could do the same thing with a built-in function from Python. Again, we won't have to build out the triangle and actually enumerate it or anything. We can define binomial distribution here. So first we're going to import scipy.stats as stats, and then I'm going to define a binomial distribution with stats binom, and I will say 7 coins with probability of success of 0.5. All right, those are the two things that determine our distributions, right? The number of trials and the probability of a success. And then I could look at something like the probability of 3 successes, and you see that we get the same value pretty much. I mean, there's just a little bit of rounding here that's off, but, and we could plot that as well. So we'll say range 8. All right, and really that's not quite the right plot. We probably want a bar. All right, and you see that we get the same thing that we had before. Okay, so next up we'll review a little more about interpreting these distributions, constructing them, finding probabilities using them.